Hello everyone, welcome to our channel. Today we are going to start the electricity chapter and this is the lesson number 1. Electric current. Before going to start the definition of electric current, first we need to know that what is current. Current means to flow, we all know that. Now there are different types of currents, like when water flows from one place to another, it is called water current. Similarly, when wind flows from one place to another, it is called wind current. Now let's see the definition for electric current. It is the flow of electrons in a conductor. So in a conductor, when electrons flow, that is defined as the electric current, or electric current is the amount of charge flowing through a particular cross-section area in unit time. Now you might be getting confused by the term this cross-section area. So to clear out your confusion, I'm going to show you one conductor. So conductor is nothing, just take a metallic wire where electric current passes through and cut the wire into two pieces. So after cutting the two pieces, we will get this type of shape. So it is known as your cross-sectional area. Now going back to the definition, see the amount of charge flowing through a particular cross-section area. In this area, the amount of charge that will flow through in unit time will be your electric current. Now what is the formula for electric current? It is the amount of charge divided by unit time. Means in unit time, how much the amount of charge is given. So how can we write the formula? Electric current is for I and the for charge it is Q and time T. So how can we write? I equal to Q by T. Q means charge and T means time and I for current. So this is your important formula that you need to know. Just mark it down. Okay. Next, what makes the charge flow? Consider the two tanks as A and B, keeping the tank A in higher position than B, and connect both the tanks. We allow the water from tank A to flow through tank B. Now, tank A is 60 degrees Celsius and tank B is 20 degrees Celsius. So tank A has higher temperature than B. Now, when the water flows to tank B, their temperature also changes and they both become 40 degrees Celsius. Now let's see what is a cell. So this is the structure of a cell, or the symbol of a cell you can say. And we all know that cell has one positive terminal and one negative terminal. The positive terminal has your higher electric potential and the negative terminal has the lower electric potential. I hope everyone knows that. It is very easy also. Now, the difference between higher potential and lower potential is called the potential difference. Okay, this is the potential difference. Now you might be thinking that why the potential difference is necessary. Because see, without potential difference, there's no cause for the electrons to drift in the same direction. So there will be no current. If there is no potential difference, that means there will be no electrons flowing through the conductor and hence no current will be formed, right? So to flow through current, we always need a potential difference. And that's why we need a cell. So what is the function of cell? The function of the cell is to create potential difference. Just keep this line in your mind. It is like you might be getting asked in your MCQs like what is the function of a cell. It is just to create potential difference. Now what is a free electron? Electrons in the outermost shell of an atom which can easily leave the atom and become free. Those are called free electrons. Here we are going to take a nucleus, and we know that nucleus has protons which is positively charged, and it is being surrounded by one or more negatively charged particles. Those are called electrons. So you can see that electrons are moving around the nucleus. Now there is a force of attraction between the electrons and nucleus. Obviously, there is always a force of attraction between the positive and the negative. And here the nucleus and the electron, they are attracting each other. And that force of attraction is called the electrostatic force of attraction. Now see, in case of non-metals like I'm considering here at nitrogen, you can know that the atomic number of 7. Okay, I'm going to write it down, but let's see how many electrons are there in the outermost orbit. So in case of non-metals, the outermost orbit has 5 or 5, 6, 7 electrons. So I'm going to give an example of nitrogen only. Okay, write nitrogen. What is the atomic number of nitrogen? 7. We are going to fill the cells. Fill up the first cell and the second cell. So see, in the outermost cell, how many electrons are there? 1, 2, 3, 4, 5. So there are 5 electrons in the outermost cell. Now see, these electrons are strongly bound. These electrons cannot be taken out of the orbit. Am I clear? Okay. Now let's see what happened in case of metals. In metals, the number of electrons in outermost orbit is less. That is, it has 1, 2, 3 electrons. Here also we are going to take an example. Consider any metal. Here I am going to consider sodium, which is atomic number 11. Let's fill the cells. First cell, second cell, and this is the third cell. Filling up the cells. So see, there are 11 electrons. And see, in the last orbit, there is only one electron. So this electron that is in the last orbit, they are very loosely bound. Okay, and hence they can be easily removed from the last orbit because they are very lightly bound. I hope this is clear to you now. Okay. Now, depending on the number of free electrons, substances are classified into conductors. So conductors, they have large number of free electrons, which are charge carriers. And we already came to know that conductors, where electric current can pass through. Those materials are called conductors. So let us take an example of conductors. Conductors like copper is a good conductor. You can write gold, and also our human body. So see, that's why we are being told that not to use the electrical appliances with our bare hands, because since our body is a good conductor of electricity, therefore current can easily pass through our body. Okay? Yeah. Next is insulators. So what is insulators? In simple language, we know that where electric current does not flow easily, means it have less or practically no free electrons. Now what are the examples of insulators? Like glass, wood, so etc. So these are insulators where electric current cannot pass through. Okay. The next is the semiconductors. So what are semiconductors? They have free electrons. They do not have free electrons at room temperature, but can develop under specific condition. So see, in general, in the room temperature, they do not have free electrons and they cannot produce electricity. But in specific condition, if we develop the condition in our laboratory, then we can pass those free electrons and can pass electricity. What are the examples? Like SIM card that we use in our mobile phone is made up of semiconductor. And the IC, which is the integrated circuit, is also made up of semiconductors. Okay, so now let's solve some questions. These questions are very important. Please go through it because in your 45 MCQs, these questions might be asked. Okay, now see, what is the first question? A substance which does not allow charges to pass through it easily is called? I'm asking you, what will be the answer? Okay, I'm helping you out. It is the insulator. As we have already read just now that the substance which does not allow charges to pass through it is called insulators because they do not have free electrons. Okay, yeah. Moving to the next question. Negative terminal is called, I already told you the answer. Okay, the negative terminal is called the lower electric potential because they have concentration of negative charge. Alright, okay. Third question. Substances which do not have free electrons but can develop under specific condition are called? Okay, what are they called? They are called semiconductors. Okay, because the free electrons are generated on imparting heat. So these electrons normally they do not flow at room temperature. Only we have to develop under specific conditions like by imparting heat or by giving heat, then only these free electrons will generate. Alright, now moving to the last question. The function of the cell is, what will be the answer? Is to create potential difference. Okay, because cell creates potential difference. Next is flow of current in a wire. So how current flows in a wire? As you can see, the wire and the blue balls inside it, considering it as atoms in the state of vibrations. And the black small balls are the free electrons inside the wire in the state of random motion. Now, we will connect the wire to a cell. Let's connect the wire to a cell. Now here we can see that the electrons are moving with certain average drift. It is not moving like one is moving faster and the other is moving slower. No, it is moving with a certain average velocity. We know that the current and the electrons, they flow opposite to each other. The free electrons here are moving from negative to positive. But the conventional current is flowing from positive to negative. Next is the potential difference. Let us take an insulated stand A with positive terminal which is high potential and an insulated stand B which is negative terminal with low potential. Now we connected the two insulated stand with a metal wire. Now due to the difference in potential, charge will flow from higher to lower potential. So see, charge has been flowing from higher potential to lower potential. Now since charge is flowing, therefore work has been done. Now let's check the definition of potential difference. The electric potential difference between 2 points in an electric circuit is defined as the amount of work done in moving a unit positive charge from one point to another point. So see, here the 2 points are the A and B, which is negative and the positive terminal in the circuit. The amount of work done. Now what amount of work done they're talking about? It is the movement of the unit positive charge. Since we saw that from higher potential to lower potential the charge has been flowing, so work has been done. So that unit positive charge from point A to B or from positive to negative terminal, it is in the circuit it is defined as the electric potential, and that difference is your potential difference. Okay, now moving to the next, that how does lightning occur? When the two clouds collided with each other, they produced some charges, and that is called the static charges. In simple language, we can define static charge with an example by whenever we rub our hair with oily hair with a comb, then we take the comb to some small pieces of paper, and we can see that those pieces of paper are attracted by the comb. So that is called the static charges. And here the clouds are at high potential, and the earth is at zero potential because it is an infinite body, it has zero potential. So the charges travel from high potential to low potential, and this is how the lightning occur. Okay, let's solve these questions now. The electrons flow from negative terminal to positive terminal of the cell, but the dash of current is from positive terminal to negative terminal of the cell. What will be the answer? Try it. Okay, I'm helping you out. It is the conventional direction. The reason is given here. The conventional direction of current is opposite to the direction of flow of electrons. We already came to know that the current and the electrons, they flow in the opposite direction. Moving to the next question. The function of the cell is to create, it's a very easy one, is to create the potential difference, as cell contains higher potential and lower potential. The last question is the potential of earth is, the easy one, zero potential, as the earth is an infinite body. Okay, this is all about the lesson number 1. I hope it was helpful to you. Thank you.